Okay. So this is Professor Dr. Ashok Kumar Gupta, Principal, Satpura College of Engineering and Polytechnic, Balaghat, MP. We are here for AICTE training and learning, that is called ATAL in short, Academy sponsored online faculty development program, FDP, on empowering faculty on Industry 4.0, 5.0 and smart manufacturing. So today's session is session 9 and today's day is 5th day. We have started from 6th of October 2025 and it is now 10th October 2025. So it is 5th day. We have seen till now session 8 by various renowned guest speakers from India and overseas. And we are very much benefited. Now 2 more days to go. That is today, that is Friday, 10th October. Today there would be 2 sessions. Session 9 from 6 p.m. to 7:30 p.m. and session 10 would be 7:30 p.m. to 9 p.m. Around 8:30 p.m. you will get feedback home. So there are 2 sessions. Session 9 is by our expert is Dr. Devbrat Datta. He is ex-senior scientist ex-senior nuclear scientist, retired and professor, joint director, research and development, Heritage Institute of Technology, Kolkata. He has shown his mail ID also on the first slide. You can reach him through mail. If you want, I can share you the contact number of Dr. Datta also. Another session, Hardeep Singh, is Professor, Amritsar Group of Colleges, Amritsar, Punjab. So, for the session, Dr. Datta would be taking artificial intelligence and machine learning algorithm in predictive maintenance. And Dr. Hardeep Singh would be taking workforce skill development for smart manufacturing. So, one thing I would like to state that tomorrow the session would be started from 2 p.m. and it will go up to 8 p.m. So there are 3 sessions tomorrow, and 1 quiz would be conducted plus 1 combined feedback, overall feedback of this FDP you have to give. So you are required to appear in both the event compulsorily, to be marked as absent. So please take care and be on time. Then we would be conducting the valedictory session. All the resource persons of 1 to 13 sessions would be there and they will share their overview regarding this FDP. So it is mandatory for all of us that we must attend the last 2 sessions, that is valedictory session and this quiz as well as feedback, overall feedback. So I request all the resource persons to send me the quiz questions in objective type forms, question related to their topic, which they have discussed in this FDP related to their topic. And almost you can send 10 questions along with A, B, C, D options and give the solutions differently. Give your solution correct answer is different. So I'll share the pattern of question papers differently to the group of experts. So I think you all have to give by tomorrow 12 noon. So that would be better. You can give maximum 10 questions of each. So those questions can be selected by ATAL portal and they will randomly come for this test. If you log out, then another set would be appeared. So it is not mandatory that if you remember one subject, one faculty member at a time, and you will be cleared. So my humble request that you can see if you have missed some portion or some day, so you have to give your you please overview the recording that is available on YouTube and that is being sent each and every time for the joining purpose. So we'll keep on doing discussion today regarding the tomorrow's session. So I request Dr. Devdutt Datta sir to start his session and we'll take a break for 5 minutes at 7:25. So please try sir to complete and keep 5-10 minutes, 15 minutes for question answer session.
Yes, sir.
Okay.
Yes, sir.
Thank you, sir. Everybody,
Yes.
please be attentive and listen carefully and be interactive with the session. Thank you, sir. Thank you.
Okay, sir. Okay.
Over to you, sir. Yeah. Thank you.
So good evening again, and nice to give the short summary of all the days, whatever we have learned so far. And today's session, I will be mostly describing the artificial intelligence and machine learning algorithm in predictive maintenance. Okay, so we have to give the presentation into this form that what is predictive maintenance, first of all, and how it works, details about the predictive maintenance, and background of the predictive maintenance will be executed by the AI and ML. So that is why background of AI ML is required. And here predictive maintenance is basically a condition type of system. So we have to give the explanation of Bayesian prediction. And using this Bayesian prediction, we have done some work that is a prediction of cutting tool or workpiece that we will demonstrate. And in the same way, we will also give the forecasting of remaining useful life of an engineering component. Okay, that is a preventive predictive maintenance because time-wise, how that the rule changes. Then we will conclude my session. Okay. Now, as I mentioned that what is predictive maintenance, you can see that for any kind of data analysis, there are two types of basic analytics. One is called the predictive analytics, another is called the prescriptive analytics. So predictive analytics is applied for the maintenance. That is why it is called the predictive maintenance. That means before maintenance starts, you can easily get the idea that what are the components in the manufacturing industry or any industry 4.0 or 5.0 should be maintained. Okay, so that if you can really apply these predictive maintenance, so systems lifetime will increase. So this is one way of defining the predictive maintenance. Another way of defining that, we always receive that is some the data. So the data we can analyze from sensors, we can have the maintenance records and many other sources. So using those, organizations can always anticipate issues, optimize maintenance schedules, reduce the unexpected downtime, lower costs, and extend the lifespan of the machinery. So therefore, predictive maintenance in short will be using real-time data which will be collected from sensor and IoT-enabled assets, and they will be combined with advanced analytics and machine learning technique to anticipate equipment failures before they happen. So predictive maintenance, before the happening, you are able to predict that what maintenance should be executed. Now the question is that how predictive maintenance works. Predictive maintenance, first of all, to execute that you require to have a data. So we need to collect the data from sensors and any other IoT devices, which will be installed on equipment to continuously collect some real-time operational data and so on. Then those data you require to analyze by some statistical method or the machine learning algorithm. Okay. Then from there, you have to have some detection of anomaly. That means normal part is okay, but if some kind of abrupt things happens, that is called anomaly, then definitely the anomaly should be detected, so that we will know at this particular time the system is behaving some erratically. Then based on that, we will have a prediction, and then after the prediction, we can take some kind of actionable insights. So these are the 5 bullets on which that the predictive maintenance will work. Now, why is that the predictive maintenance? What are the benefits? Benefit is that it can reduce the downtime. That means equipment is maintained only when needed, minimizing the unplanned outages and ensuring higher asset uptime. You can have a lower maintenance cost. That means maintenance is performed efficiently, avoiding unnecessary tasks and preventing costly emergency repairs. We can go further the extended asset lifespan. We can also improve the performance if we can time to time maintain our system. Then overall, we will have enhanced safety. Safety is always important for any kind of operational procedure. So therefore, enhanced safety can be achieved by using the predictive maintenance. So these are the most important benefits of the predictive maintenance. So predictive maintenance basically use straightway machine learning. And why? Because in the machine, because whenever you have the data will be the multivariable set. So you cannot have the homogeneous data. You can expect that the data from the different area. So therefore, fitting those data in a normal regressive mode or some functional closed form expression may not be possible. So we require that some non-parametric technique, and machine learning is basically a non-parametric technique. So therefore, predictive maintenance always use the machine learning. So therefore, we can say that the machine learning will enhance the predictive maintenance by analyzing the operational data from sensors to forecast equipment failures. It can also go for the optimization maintenance of the schedule. By identifying the patterns which will indicate that some kind of issues are there, so we can always go for a proactive intervention by allowing ML, other machine learning. So this is the basic task of the machine learning in the field of the predictive maintenance. So we require to know that though people are already knowledge about the AI and ML, but in general, because AI ML is basically very oceanic subject, but which component of the AI ML should be applicable for preventive maintenance? That is my concern into this lecture. So in general, if you look at that, AI refers to some computational tools, okay, which will be substitute to the human intelligence in the performance of certain tasks. An AI process will include learning, learning from the system, and also it will give the reasoning. So therefore, these two, learning and reasoning, these two sequentially, if we can process, so that will be called as the AI process. Coming to that part, that AI is basically always equipped with the two other intelligence. One is called the brain informatics, another is called the cognitive intelligence. So therefore, we can have the human intelligence by combining all these AI, BI, and CI. Okay, so therefore, human intelligence also can be developed by using the AI. And this human intelligence, if we can make into a form of a product, then we call that it is a robot. So robot is be having the three components: this artificial intelligence, then brain informatics. Robot will be having some brain, and then it has got some kind of sensing, which is a cognitive intelligence. So we can say that the complete artificial intelligence should be achieved in a computer using some algorithm, and these algorithms are generally known as the machine intelligence algorithm. And intelligence will be governed by learning. Whenever we say that the intelligence, so that intelligence nothing but the learning. Learning is not that the sequential, but it is sometimes random also. Okay. So from that, we categorize the AI into two domains. One is that the weak process, that is weak AI, which is a narrow learning, that is basically classical AI, or we can have a strong learning, that is called quantum AI. So two category of AI is devised. One is the narrow learning, another is the strong learning. Narrow is a classical, which we generally apply for the normal task. But if the data is a huge or big data, then in that case, we have to have the strong learning, and that will be done by the quantum AI. See, quantum artificial intelligence. And quantum artificial intelligence is alternately called as a artificial general intelligence, AGI. So there are some components of AI. Components of AI always will be based on some applications. For example, image recognition, speech recognition, chatbots, natural language generation, and sentiment analysis. There are three types of model. One is the deep learning, machine learning, and neural networks. And corresponding to that, we may have the various kind of software or hardware, like you require to have the GPU. Many of the times, CPU will not allow you to process that. And then parallel processing tools, cloud data storage, and then programming language. Generally, we use the Python or TensorFlow. Some people use the Java. C and MATLAB people use, but not that much of efficient compared to the Python and TensorFlow. So this is the category of AI we have mentioned, but this is the type of artificial intelligence. In this C, you are seeing that the type 1, type 2, type 3, and type 4. These are the four types of AI is there. If it is a type 1, that is the reactive machines. Example, that the Deep Blue, IBM chess program, Google's AlphaGo. If it is a type 2, then we have a limited memory. That means these AI systems can use past experiences to inform the future decision. Then type 3 would be the theory of mind. That means psychologically it will believe. So you have to have some belief kind of system into the type 3 category of type 3 of the artificial intelligence. Type 4 is the self-awareness, where AI systems have a sense of selfing, having some consciousness. Okay. So examples of AI technology is very obvious, that automation, machine learning, as I mentioned, machine vision, and then NLP, that is natural language processing, like Meta AI, you always use the NLP, or Meta Llama, you always use the NLP. Then we have a robotics or some kind of self-driving cars. These are the various technology, and there are many more. I have just talked out these applications which are now available in many of the events. So now you see AI can be applied in healthcare also. AI is applied in business also. AI in education, as well as AI in finance, law, and manufacturing. So our domain is to cover almost the one or two extent that is some manufacturing domain. Okay. So now think that whenever we talk about the AI, it is an artificial intelligence. That means the Alan Turing in 1950 posed this question: can machines think? So Turing's paper was very famous paper in 1950, which was the title of the Computing Machinery and Intelligence, and its subsequent Turing test established the fundamental goal and vision of AI. Okay, so there are 4 different approaches by carried out by Norving and Russell. They have a very good book, and these 4 different approaches for implementing the AI is nothing but that you think that the humanly, that means the way that the human can think, machine also can think. You think that the rationally, some kind of justification also while thinking process possible, acting humanly or acting rationally. So therefore, this thinking humanly and thinking rationally, these are the thought process and reasoning. And whenever you act on that, so it is basically behavior. So whenever you design AI software, you have to give the thought process and reasoning technique, and then you have to execute the behavior also. So these are the basic concept of the artificial intelligence. In the artificial intelligence, the universe, in that you have a machine learning. So machine learning is a subset of AI, and then deep learning is subset of the machine learning. So this way we have to do. So if you have to go to the deep learning, therefore definitely you require to understand the machine learning. And when deep learning and machine learning you understand, that means you can have a AI-based product. There are many disciplines. You can see that the machine learning can connect to the many domain of the subjects like control theory, game theory, information theory, psychology, optimization, and so on. So whatever people required in their manufacturing industry or the industry, so they can connect to the machine learning into that domain for predictive maintenance. So now the question is that many of the time people say that they're learning, but what basically we learn? Because any of the artificial intelligence always is the machine learning. But what exactly it learns? Okay, we are giving some data. It understood the pattern, but in that, what it learns? Herbert Simon mentioned that learning is any process by which a system improves the performance from experience. So what is the task basically? Task can be a classification, maybe a categorization or clustering. It can be a problem solving or planning or control. It can prediction and many others. So that means we have to strategically define that what is learning. Okay. Now there are many of the learnings are there. Human learns sometimes by rote learning. That means you are memorizing the whole thing. So modes of learning can be induction versus deduction. Some of the people are good, some of the students are good. The way they are learning, we discuss with them, and then we are learning also ourselves. So induction versus deduction is one of the mode of learning. Rote learning is a very common learning. Advice or instructional learning, we can learn by example or practice, because if you do some 5 problems, another 6th problem you can always do once you learn that. So learning by analogy, discovery learning, or many others. Okay. Machine learning for predictive maintenance is used as basically a function approximation. That means after implementing the machine learning for the data predictively, we require to map a function. And this function mapping is known as a regression. It can also classify, that is a classification. We can do the categorization, that is a clustering. And then we can go for the prediction and pattern development. So these are the machine learning general domain: function approximation, classification, categorization, prediction, and pattern recognition. Different varieties of machine learning takes place from that. You can have a concept learning, you can have a clustering algorithms, connectionist algorithms, genetic algorithms, explanation. These are the all strategy of the learning. So depending on your problem, which component you are basically using for machine learning, so your algorithm should be designed from that angle, and then you can code that language, because nowadays coding is very easy, and then you can always analyze your outcome. So here you see that you have a reinforcement learning, you can have a case-based learning, Bayesian learning. I introduced the Voronoi-based learning. Voronoi is a very good subject of the computational algebra. We can do that the Voronoi-based learning, and also we can have the fractal learning. So you can have a learning strategy in the manufacturing domain. Is it a fractal or not? If the fractal, then by running the fractal, you can cover many area of the component. Then overall, we have a supervised learning. When we talk about the supervised learning, that means we have a data. Okay. One of the example of the decision tree tools, prediction of the future cases, we can use the rule to predict the output of the future inputs. And from there, we can extract the knowledge, that is the knowledge extraction. And then we can concise, or we can compress that rule, because rule can be a very big rule, and it is a if-then rule. If this is there, then and or like that only, it can be very big. So we can compress that the rule is simpler than the data it explains. Then also we can detect that the outlier intelligently. Otherwise, your machine learning algorithm will take more and more to convert the decision. We have a unsupervised learning. When unsupervised learning, the data is there, but it is not sufficient. So therefore, with the help of the minimum data, it is not labeled data, first of all. So you can learn that by supervised technique, and then like a clustering. Okay. So if you do the clustering, that means you are grouping the similar instances, and from there you can find it out that clusters are there. For each cluster, you can learn then by supervised learning. So unsupervised learning is very important when your data is scattered or not having any correct pattern. Okay. So you require to have a clusters. Generally for big data, we can go for that. Then reinforcement learning. Reinforcement learning is nothing but that you are learning not as a whole, but incremental learning. Each and every step you are learning by having your feedback. The way that the ATAL FDP is going on, you are learning each and every day by incrementally. So reinforcement learning is nothing but that type of thing where you require no supervised output but delayed reward, credit assignment problem. And these are the applications generally for reinforcement learning, like a game playing, robot in a maze, or multiple agents like that. So we learned that the supervised learning, we discuss about the unsupervised, and then we have a reinforcement learning. Now, when you do the learning, then always we require to have that how we design a learning system. To have the designing, first of all, you require the data, you explore the data like exploratory data analysis. Then you choose that some training experience. The data will be splitted into two parts, training part and testing part. In the training part, we train the data. Then whatever generally 70% should be used for training, 30% will be used for your testing. So training over, then with that training function, we go for the testing. Once the testing is out of the 20%, 15% we can use for testing. And then once the testing is done, remaining 5% you can use it for the prediction. That is why a learning system can be implemented for predicting the whole thing. So you have to basically choose how to represent the target function, then your learning algorithm, and then if your learning algorithm is choose that I have shown here by bullet, and then from that you can get the knowledge. That knowledge can be disseminated and into the form of the performance element. Here one example I give. Suppose we are trying to learn the classification problem, whether the cancer is there or not in any. So I have given a table, the patient ID 1, 2, 3, 4, number of tumors. For patient 1 is having 5, 3, 7, and 2. Then average area, average density, and then diagnosis. So the classification is done, and then you have the malignant, benign, and malignant. So as it is a classification, either it is a malignant or benign. So this particular data will be using for training set, and then the bottom portion of the table it will be used for the testing set. So once the training and testing will be over, so classification is known, and that we can use it for then prediction. Is if there is any unknown data. For example, that here one patient number 104 we do not have. So if we give the patient number 104, provided we have the data of number of tumors, average area, and average density, and if we fit this input in the testing model, training model, it will tell me that what kind of diagnosis it has been taken either as a benign or malignant with respect to the problem of the cancer classification. So classification goal is that you use the training set plus some learning method to produce a predictive model. Use this predictive model to classify the new data. That is the basic summary of your classification problem. So there are many applications which are tabulated here: medical diagnosis, optical character recognition, protein folding, and some kind of research paper acceptance. Also, you can find it out. Okay. So potential implications for the predictive maintenance will be the robot-assisted production. You can have the predictive maintenance. You can have the additive manufacturing of complex parts, machines as a service, then big data drive quality control. You can have the production line simulation and smart supply network. These are the overview of all the potential implications of the predictive maintenance using the machine learning technique. So we are talking about the use of machine learning in robotics. There are areas that robots are required. Industrial robots are there, military, government, or space robots are there, and there are some service robots for home, healthcare, or any laboratory usage. Why are the robots used? Because some kind of tasks which are really not possible by human to carry out, then robot can be done. Repetitive tasks can be done by robot. High precision tasks can be done by robot, and there are some labor saving tasks is there that can be used. So for this purpose, robots are used, and control technology will be the autonomous, that is a self-control, or sometimes you can have the tele-operated remote control. There are many kind of applications are there for robotics side. So some of the industrial robots I showed here, it can be applied for, you see that in manufacturing domain, we require the welding, you require the painting, cutting, dispensing, assembly, and polishing or finishing, or sometimes material handling. So the robots can be very well applied on this domain. So here you see that some kind of gripping and all this maintenance are doing on. So that can be done. That cannot be done because these are the hazardous substance. So you have to apply that master slave manipulator, which are basically called as an industrial robot. So industrial robots are basically automated. Huge tasks can be done at the same time by giving some command. Then we have the service robot. Service robot always is applicable for our health humanitarian application like lawn mowers, surveillance, mining applications, construction, and so on. Then the general model of when the robot you are using is a general model for learning agent. You have the performance standard, you do the critique. So from the environment through the sensors, you are feeding the data. So you get the feedback and you feed into the learning element. What is the learning goal you are prescribed? Then you generate the problem. If there is a thing, then you can put the agent by performance element, and from the performance element, you can find it out what is the effect or not. In between, if you require to communicate that the learning element and performance element, they can communicate with each other. So this is a general model for learning algorithm. So maintenance evolution is that you have a reactive, that is a fixed when equipment is down. You have a preventive, that is a scheduled maintenance. You can have a condition monitoring, or you can use use analytics to predict failures. And this part only we are discussing today, which is a predictive maintenance. Okay. And this is the way that a maintenance starting from reactive, preventive, condition, and then goes for the predictive. Okay. So Industry 4.0 and predictive maintenance, these employs the advanced analytics that we have already cleared now. You have a sensor, you go for the computation, and you act on that. And ultimately, you are going to have a remaining useful life or lifetime of the systems in the manufacturing domain. So these are the various circles of the predictive maintenance. You can see, you can do the lower maintenance cost, you can extend the equipment life, you can reduce the downtime, which I explained. So this is a graphical explanation. Improve the production, you can lower risk the exposure, you can also recover the loss or revenue. So that is why predictive maintenance is applicable if we wanted to achieve all these goals. So we can also have a high energy density for the material. You have a sustainable battery. You can quick charging the approach, and then from that you get the long battery, longer duration. you can have the affordable battery, and finally, once you do the process, you can go to the battery safety, and that can be these are the key pillars for showing that the battery of the future technology. So examples from real life scenarios are the find the defective bearings long before the defects are visually seen. Find misalignment between two rotating pieces of equipment. Recognize when hands become unbalanced. Identify when bearings need lubrication. And report when an electrical connection needs to be tightened. Alert when oil is contaminated or in need of replacement. So these are some real life scenario examples from where we try to achieve the predictive maintenance. So predictive maintenance problem is that if you put the question, will the equipment fail in a given period of time for the next 7 days or next 1 month? Yes or no? So then you can also put what is the remaining useful life or the time to first failure. Okay, I have purchased a bulb and how long it will work, I do not know. So I can put a question, can this bulb will go up to 1 month without any maintenance? Okay. Then similarly for many other equipment. So how to quantify wear and tear? Is there any anomaly in the equipment behavior? How best to optimize the equipment settings? So these are the general predictive maintenance problems. So you approach problem definition, you select your problem, you define that problem, whether it is a classification or regression. If the classification, then whether it is a fail or success, will it fail? That is the question we put. If it is a multi-class classification, then it will always mention that whether it will fail for some kind of reasoning. And if it is a regression, then it is saying that after how long will it fail? Because regression problems are time dependent. So it will show you that the trajectory of the behavior of the system, and if the trajectory is abnormal occurs, then at what time it will abnormal appear. So you can mention that after how long will it fail. There are many methods to do all these tasks. One is the traditional machine learning, where you use the decision trees, random forest, gradient boosting, isolation forest, and support vector machine. You have a deep learning approach, that is CNN, convolutional neural network. You have a recurrent neural network. You can have a hybrid of deep learning and physics-based modeling. Okay, and many of the people, they apply the physics-based modeling, like physics-inspired neural network nowadays is a hot topic for manufacturing industry. We do not know how to solve, so we apply some physical laws, and then from that we generate the neural network rule, and that rule we further apply for predicting the system. So predictive analysis 4.0 is nothing but a branch of data analytics. That only one has to know. Performance metrics such as the cutting force and tool life, these are the important factors which will influence the productivity of the manufacturing process. So actual predictive analytics techniques are basically a machine learning, either classification or regression. So we are applying a new technique as a machine learning process in the predictive analytics domain, that is called Bayesian-based predictive analytics. When we talk about Bayesian-based, that means the conditioning things will happen. That means previous day it was not failed. So taking that route, whether today it will fail or not. So whenever we are applying this kind of conditional system, we call the learning strategy the Bayesian learning, and predictive maintenance should be obviously called as a Bayesian-based predictive learning. So Bayesian-based predictive analytics will give you a reliability of the system, tool life and reliability and tool wear growth. And this is basically an inference as a probabilistic method. So this is the overall mathematical technique for Bayesian prediction. You see that we are trying to get this is a posterior probability. That means we are trying to map the new condition that the X is known to. And this is as per the Bayesian theorem. We model it into this way. That is the likelihood, and this is your prior probability. And since this is a probability picture, so always we require to have some normalizing constant. So whenever we try to maximize this, so we try to maximize this. That means we are probability x is equal to 1 because normalization constant is taken as a 1. So we are maximizing of the log of this. When you do the log of this, that means we are taking the log of this part, which is the log likelihood, and this prior. So obviously, if we take that product as a log, it is a summation. So ultimately, my maximization of this probability to determine the new will be modeled into this. So therefore, this particular simple expression we apply as a Bayesian technique, and we get the knowledge at each and every step, and that knowledge as a feedback we apply for the next step. So in this case, we always say that Bayesian approach to predictive modeling incorporates the prior knowledge or initial belief. Later on, it gives the posterior belief. So when the system is converted, that will be our actual model. It is a totally data-driven approach. So we have the lot of applications. One is the probabilistic prediction of cutting force. We are trying to cut some kind of metal. So how much cutting force should be applied and which direction should be applied. So that can be always done by the Bayesian technique. And this is based on the Bayesian Markov chain Monte Carlo approach. And then we have the prediction of cutting and plowing forces using the probabilistic method in the turning process. So ultimately, our idea in the manufacturing domain that how the information flow proceeds toward the cutting tool performance. This is the cutting tool design process. You have a design and prototype. You have a machining experience. From here to here, and here to here, if you go, you have the tool performance, and from design to machining performance, you have the prototype. So that means this whole structure is implemented using some Python language programming in following some machine learning algorithm. And here you see I'm showing some results. Input are the cutting parameters, that the cutting speed or feed rate, tool geometry, that is the rake angle, tool edge radius, and tool and workpiece material, that the flow stress and elasticity modulus. And then we are feeding this information to calculate, and from there we are getting the output, that the cutting and feed forces, how much it should be, what should be the chip thickness, what should the temperature should be maintained, stress and strain rate, friction energy, and surface energy. And this part only will be done by some FEM software, and the input will be fed, output you will get that. When you do that, so the complete thing for Bayesian predictive maintenance is a prior model of the parameters, priors of the model parameters. You are feeding into the Bayesian increments. You are setting a training set, and from there you get the posteriors of the model parameters. Then you are feeding into the again Bayesian inference for training the model parameters. Finally, you will get the posterior model parameters. So ultimately, the Bayesian system is giving you that if you feed the model parameters of this distribution for posterior, you are getting this kind of likelihood and prior. And then when you feed that again further, so this particular thing is tuned to know that what should be your posterior belief, and that can be applied for the actual operation of the system. So what the result is seeing that is a scanning force microscope image of a diamond turned electroless nickel surface. These are the material electroless nickel tool. Nose radius is given here. Feet per revolution, 4.8 meter. Lubricant is the mineral oil, and roughness is given as a 3.4 nanometer. And we are getting this result. This particular example has been borrowed from this particular paper. So they have nicely explained. So ultimately, the application is the Bayesian learning for predictive maintenance. This is again, this is the electroless nickel plated mold for an F theta lens. And we can see that during the time, a white light interferometric image, how it is formed. And this is a schematic of the hologram for this turned into a copper nickel zinc substrate. So this way, predictive maintenance can be done. We can see that whether it is a performing copper or not. So this algorithm is nothing but that we apply the Markov chain Monte Carlo. So whenever you go for the Markov chain Monte Carlo algorithm, we require to have some metropolis algorithm for sampling. So this is the various algorithm. I am not going to discuss the complete algorithm, but we have to know that ultimately we are trying to calculate to the acceptance ratio by computing the posterior distribution, and then in that case we are generating some random number uniformly distributed, and we are seeing if U is less than some design choice, less than equal to R, then you accept the proposal. If not, then you reject the proposal. So this way the decision can be made for your cutting force prediction in the orthogonal turning process. Okay, these are the final. Again, you are going for that, and see that if you flow that, compute the posterior distribution, and you get the acceptance ratio, and then acceptance ratio will be decided by this kind of technique, that accept the proposal or reject the proposal depending on the condition which are mentioned here by mathematically. So the outcome will be that you have the joint distribution of beta and tau. You can see that and this is one distribution, this is one distribution. So when you have a joint distribution, the conformal mapping of this showing in here, and here we are showing that uncut chip thickness. Okay, this is a prior. Okay, and this is the training set, and then the training forces are nothing but that. So we can easily apply at which thickness of the uncut chip we can apply how much training force. Similarly, here also we are thinking. So here we are applying the prior functions of the tangential forces and feed force in the right side. And whenever I do, since it is a uncertainty can be possible, so we are taking the plus minus 2 sigma as a uncertainty, which is nothing but the standard deviation. Again, joint PDF for beta A and tau S. These are the three learning parameters. After the three updates, we can see that how system learns, and then you can compare your left means KT value, left side, this is the right side, which is the prior and posterior. This is the prior distribution. Okay, this is the prior distribution, and this is the posterior distribution. The acceptance will be taken as a posterior because initially we do not know what kind of prior. So the data will give you some kind of fitting, which is the likelihood distribution multiplied by the prior, and then we will get the posterior. So ultimately we are accepting as a outcome of the posterior distribution. Now this is the Bayesian method. Second type of thing that when to use the deep learning to predict the failures. If you put this question, is the accuracy of prediction more important than interoperability, interpretability? Are there frequent changes in the asset configuration? Are there traditional approach? So many questions, if it is coming to mind, that time only we have to use the deep learning technique. So because learning may not be sufficient, so we require to extend a lot of layers, and that is why it is called the deep learning. And also we have to see that if there are correlated or not. Okay, so two-step process will be there. One, you are going for the training, and training network will be there, and then you are trying to get the inference. So in case of the deep learning, you are having so many layers through which you are learning the pattern. By using that, you see this is the input layer, this is the hidden part, and this is the outcome. So from that outcome, you are taking what kind of inference can be done. There are many ways that the cloud computing can be implemented for deep learning phenomena. If the data is huge, data transmission cost, network bandwidth, network latency, many of the parameters are required to have the cloud versus edge processing. Okay. Then we can apply a simple realistic predictive maintenance for estimating the remaining useful life, which is one of the example predictive maintenance domain. Okay, so that means in this we are required to know what is the rule model should be suitable for your system based on the data. What is remaining useful life? As I mentioned in the first lecture, remaining useful life is nothing but the time when it is started operation and the time when it is just trying to fail. So the difference between the time is nothing but the remaining useful life. So there are three common ways to estimate that. You can use the survival model, or you can use the degradation model, and you can use the similarity model. So these are the models generally used for estimating the remaining useful life. Remember, survival model, degradation model, and similarity model. Okay. So I'm trying a realistic example, which is a use case. So predictive maintenance of the electromechanical actuator. This is my electromechanical actuator. It has got the many components like electric motor, is the gearbox, this is the lead screw or ball screw. This is the again lead screw or ball screw. And then if you come to the diagram, this is a guide. These are the coupling takes place, linear bearing and gearbox. So these are the various components of an electromechanical actuators are there. Many other components are there, which is taking the actuation by electrically. So we wanted to calculate the remaining useful life of this system. So as it is a electromechanical, so we have an electrical machine where electrical machine is governed by so many parameters like power density, maintenance need or not, then reliability. So these asynchronous machine, permanent magnet synchronous machine, this is the switch reluctance, and this is the another machine called the SM mode. So therefore, there are many types of machine varieties that there where electrical data can be collected by running the system. So you can see that there are various ways of electrical contacts are there where we use the electromechanical actuator. One of the application is that our aircraft, and another is that for advanced motor drive. So whatever we have, it has got the two parts. One is the electrical part, another the mechanical part. So electrical model of the motor is governed by these expressions. There's the voltage. We have the voltage equation for the armature circuit. We have the mechanical model of the DC motor and load, which is given by this is equation. So we have a set of equations for electrical part, and we have a set of equations for mechanical part. And also we have that some kind of lead screw and ball screw that can be done by this expression like a x, and this is the velocity, the linear motion. Okay, so therefore using this we have to have a force generated by the actuator, and here when you have the force generated, so we can also calculate the T load. So these are the coming from closed book relations. So these equations can be modeled into a dynamical platform like rate of change of current, which can be governed by this expression, and mechanical dynamics can be governed by this expression, and linear position velocity can be governed by this. So these coupled equations always can be modeled. Now what happened? The whole system we can write in the form of a state space representation. So if you write that we define that variable x1 as a IA and variable x2 as a omega m, and then convert the whole equation into this coupled ordinary differential equation, that x1 dot and x2 dot and also x3 dot. So these are all my first order ordinary differential equation, which is a coupled. So therefore, this whole component again for modeling can be converted into a common electrical network circuit, which is given by this expression. And I am not mentioning that because already it is mentioned here. So nu is equal to R1 into omega, and tau L is equal to R2 into M. So this all these systems electrical equivalent circuit we can give that. Having that, then we can also mention some terminology like K tau is R2 into Tm, Ke and J inertia. And we have the impedance into this form, and the corresponding equivalent circuit is given here. So you can see that it is given. So from there, we can calculate the efficiency of the actuator. These are all prepared in the industry. So these again for using Kirchhoff's voltage law, you can write down the whole equation in a systematic manner where features like reliability, average power consumption, and cost are the examples factors. So finally, the industry will provide you the parameter like nominal stroke, maximal axial operating load, maximum axial operating load for tensile, ambient temperature, cooling, power density, fault tolerance, efficiency, and inverter, everything they will be providing. And you will feed into that equation. So when you go for that, you have to have a loss models. Loss models is the iron loss model. that can be used into this expression depending on the operation, and the losses are originating from the alternating current that can be superposed to the DC losses. This all the models I have mentioned here. So this is the resistance part of the DC losses. So when you having this thing, when you go for the actual 2D FEM analysis of the electrical machine, we got a grid plate of this, and with the no load potential, the variation arc length with respect to this parameter Bn, that is magnetization, we can easily feed into that. Then we got the electrical machine outcome, 2D FEM analysis. The outcome came from the FEM software, open source software we have used. So using that, we got the amplitude percentage and phase different way. Okay. So then we apply a graphical plot to understand how the pattern changes with respect to the angle, and with respect to the angle, and which output is nothing but it is coming as that nm dynamic, that is a torque part is calculating here. The equation is given here. Fine. So we plot the losses, and manufacturer loss data is given here, so that in the 3D mode we plot that after the analysis. And these losses are basically modeled by average of the magnetic field, that is the flux density, and flux density can be calculated by using which is 0.83, and graphically we have shown into the difference there. And when you mix up, you will see that a nice pattern is showing. If the pattern is showing this one, that means it is okay. If there is an abnormality, you have some kind of disruption technique from here. So these are the losses we applied. So ultimately, when you go for that actual reference load torques and angular velocities, you can see in the manufacturing domain, these are. So all the information either in the graphical form or in the digital form, it is with you. So you have to know that for unknown events, whether how we can learn the whole system. So this is again another setup for angular velocities and voltage machines actuator. And now here again, various parameters we have taken and run the operation. So these are all same. Now when you do for that, the question comes here that what is the problem? Problem is that the idealized actuator cross-section in the 2D domain of magnetosphere. So we simulate the complete magnetic circuit representing a cross-section of the EMA, which will involve a core made of iron and air gap and a coil carrying current. So goal is to solve the magnetic vector potential in 2 dimensions, from which you can calculate the magnetic flux density and flux lines. So therefore, you take your simulation grid size x equal to 50. In the y direction, you have taken 50, and the domain width you have taken 0.1 and domain height 0.1. These parameters are to be given by the industry. So then another parameter mu 0, mu r iron, all these parameters will be given. And when you run that your software, you see that the FEM solver is started at the different iteration. You are getting the maximum liberation, and after some time, when you see that it is achieving a very high precision, so solver will be stopped. So then outcome in the graphical form, it is a magnetic vector potential you can see, and this is the magnetic flux density. So you got the output, and you from there you can learn the whole system. So that is why it is possible to maintain the whole system predictively by taking the machine learning technique. So model-based prognostic, when you do, it is a physics-based failure. You update the POF model by Bayesian approach, which I showed, and in the Bayesian you apply the Markov chain Monte Carlo, and if it is a non-iterative, then you update by analytical technique. So this is the one stator part. This is a model-based, that is POF-based model, physics of failure basically. Health prognosis for the power generator stator windings. Okay. So you have the coolant leakage, then you can also have a various type of cooling and cooling water, copper stand, and you can model the capacitance if it is there in that. So having that, manufacturer will give this all the different steps. So they will define the electromechanical actuator parameters, RA, LA, armature inductance, this is armature resistance, this is the back EMF, this is the torque constant, then mechanical parameters they will define, they will give the discretized state space model. So that state space model will be done by the Kalman filter. So you are basically solving the whole system by using a Kalman filter. Then Kalman filter best you can predictive mention. So if you run that, you see that the armature current is flowing, motor angular velocity is giving, and then linear actuator position is giving. Finally, you will get the applied armature voltage. So this way, the complete set of equation is converted to a state space model, and then Kalman filter we are using. So Kalman filter then can be used as a predictive maintenance tool. Using the Kalman filter, we can estimate the rule for a single actuator over the time. So Kalman filter is a data simulation. It is a time series degradation. For a Kalman filter, we use the degradation of a single actuator over time, where sensor readings become noisier or drift as the actuator degrades. Okay, so the true RUL decreases linearly, and sensor readings show a trend with added noise. So this is a system for applying the Kalman filtering. But remember, Kalman filtering is going for the sequential estimation. You require to design total cycle, and you have the standard deviation. So this is my simulated data. Cycle I have taken 5, true RUL calculate, and sensor readings we have done. Okay. Then outcome of the Kalman filter is based on the true RUL, sensor readings, estimated RUL we calculated, and estimated degradation rate. So you see that some of the time, because of the noisy data, you have some estimated slightly higher. So therefore, this when do the true minus estimated, you will get some kind of minus figure. So this is the graphical presentation for the mean absolute error, from where you can use how the Kalman filter as a predictive tool is using for rule estimation. Then there are many improvement takes place. You can have the variation of the extended Kalman filter, which is the degradation modeling. That EKF is nothing but the extended Kalman filter. Then also extended Kalman filter we can use for the remaining useful life for the estimation logic. These are the variations as a research problem. You can always take it into account. Then when you run that program, you will see that where the notch is coming. So you require to see the abnormality into this particular cycle. Then here also same thing. And when you go for that, it is ramping, and then it is getting saturated. So therefore, from here to here, you require to execute the maintenance. So that is the predictive maintenance. This is the linear actuator position. This is the viscous damping, and this is also the remaining useful life estimation. So the various stages you will get that, and finally you can predict that the new actuator readings, actuator 1 reading, predicted RUL you can get, actuator 2 readings you are having, you can fix the predicted rule. So different based on the different readings, you have the rule. These are your unknown, okay, because you are predicting for the new actuator, and based on that, if you plot that, you see that your actual versus predicted remaining useful life